So we're going to be doing another histogram Excel work today for our activity. Let's start by reviewing what we did last time. So last time we made histograms of penny mass data and scatter plots. So this is a scatter plot of year and the mass of the penny. You can see that the pennies were approximately 3.1 grams until 1982, and then there was a jump down in here to 2.5. So what can we infer from this graph? Something happened right here in 1982 with the penny. So here's another graph I just made of a mass of pennies for a longer time period. So here's 2020. Here's 1982. There was a jump from the 1970s to the 1980s, and then this is the penny mass information for the 20th century. So what's interesting about this graph versus the other graph is you have more data points, so you have more present-day data, but then you also have this data point, 1943. What could have happened then? So if you look up the history of the pennies, you see that they use different materials to make pennies. Since 1982, they've been making pennies with different materials, and in 1943, think about what's going on in the world. There's a World War II is happening, and they needed the copper to make munitions and other war-related things, so they used, I believe, tin to make pennies, which weighed less than the average, than the copper penny. So you see some sort of information here given by this graph. So if I have a graph, scatter graph, I can often infer something interesting is happening in these graphs when I have like what I'm going to call a bump in the data. There's some sort of data, and then all of a sudden there's like a little interesting part, like something is happening here that doesn't fit the theoretical penny. So if I have like pennies, I always know what their mass is. Pennies, the mass is never going to change. And if there is a change, then something interesting is happening there, and that's what I'm interested in learning today. So I'm going to be making histograms. I'm going to be making histograms today of data from the LHC. Okay, so people have been struggling with Excel histograms, so I'm going to show you how to do that today as well. Let me go to home. So the first thing you need to do is to go to the CERN website, and the CERN website and download the file. So I'm going to give you a link for that, but here it is. It's opendata.cern.ch.record.700. It's kind of hard to find unless you have the exact link, because if you go to Open Data is part of CERN where they just release data sets to the general public. So the general public, if you're a scientist or an amateur scientist or even a student, and you want to use the data from the Large Hadron Collider, you can click, and it looks like they've changed this since I used it last, but it looks like you can filter out what kind of data you want to use. You can get a data set and then analyze it. Why do they want to release data to the public? Well, you know, it's publicly funded scientific research. Also, you can actually go and use this data set in a science fair project or some other project and actually discover something that scientists haven't discovered yet. Sometimes people find, you know, they have an idea for how to manipulate the data or solve for the data. And so these data sets are real research that has been collected from the Large Hadron Collider, and if you want to explore it and analyze it, maybe you can use that for science research on your own. And people make discoveries all the time with these open data sets. Okay, anyway, so if you go to this part of the open data website, records/700, you will find the data that I want you to work with. So if you scroll down about towards the bottom of the page, there's some files, and these are comma separated value files that you can open in Excel, CSV files. It's what we've been working with. So there's several runs of data here, 1, 2, 3, and run 0. So there's 4 runs, and they're each 1.4 megabytes. But I recommend you use, so you can use any of those that you want. I'm going to use the full data set, which is 14.5 megabytes. So it takes a little bit of time to download depending on your connection speed. Okay, so I've already downloaded this. It took me like a minute to download. It's right here. So let's show in folder. It's in my downloads folder. I'm going to drag it to my desktop and then open it in Microsoft Excel so I can show you what it looks like. Okay, it's opening up this file. Wow, this is a lot of stuff. I have no idea what it means. Well, let me tell you what it means really quick, and then you're not going to use most of this. This is just the run number, so there's lots of different days that they take data. They take data pretty much continuously most of the year when the Hadron Collider is operating. So these first two just identify like when it happened and what the run number was. I don't know what G means. I'm sure it means something. E1 is the amount of energy detected in one of the calorimeters, which is a detector. It detects how much energy came out of the collision. PX1 is the X momentum. PY1 is the Y momentum. And PZ1 is the Z momentum. So if you imagine that you can you have a particle that's three-dimensional as X, Y, and Z components, and these are like mass velocity. Momentum is mass times velocity, so it's like energy. It's sort of a measure of how fast and how massive the things are going when they collide. This is called the transverse momentum, which is like sort of like it's kind of hard to explain, but it's like so these are vectors, the x, y, and z components is kind of like the sum of the square roots of them. 801 I totally is associated with this, so I can represent x, y, z as this and this. It's like going into polar coordinates or something. But don't worry about this stuff if the math doesn't make any sense to you. You're not going to actually use any of this stuff in what you're doing today. Phi 1, again, goes into, it's like another way of expressing it. It's like you can imagine, I don't know if you've had the math yet, but if you have, this is like the radius, and these are like the angles in polar coordinates. So there's two different ways of representing the momentums. Q1 is, I don't actually know what that is. And then here's the second detector, the second energy detector, so forth and so on. These are more momentums, and a different way of doing the momentums. Now, forget about all this stuff. So all of these columns, like you're not even going to use these. If you want, you can delete them all. What you're going to use is the mass column. The very last one is the mass. This is sometimes called the invariant mass, but essentially, this is the mass of the penny. Think of it like that. Like, you don't have the year of the penny because it all was created in the collider at this time, but this is the mass of the collision. So that is what you want to make a histogram of. So you're only using the U column, and this mass can actually be calculated using the momentum and the energy information, if you so desire. So you can actually double check your mass calculations, but we're not going to double check. We're just going to assume CERN did a good job in calculating these. All right, so you have a mass. How do I so if this whole stuff really scares you, you can just highlight all of this stuff, right click on it, delete column. Look at that. That's all I want. All I want is the masses. So look, 2.73, 3.1, 9.4, 7.74. So if I scroll down, it gives me a bunch of numbers, and man, there's lots of, how much data do I have here? So if I use the 14 megabyte set, scroll all the way to the bottom, you have 101,000 data points. That's a lot of data points, 101,000 data points. Actually, -1, so 100,000 data points, okay? And I want to make a histogram. So, I mean, one way you could do this is copy and paste. So if you're really dead on Excel and just want to get a histogram and get done for the day, you can just copy and paste the first 499 of these. So Control C, and then go into the easy histogram maker that we studied last time. So this is just, I just Googled easy histogram maker to get to this website. We did this last time as a way to, if Excel was broken or whatever. So you can copy and paste your information in there. I did this earlier. You need to have less than 500 data points. Won't let you do a histogram unless you have 500. So here's the histogram that it generates. And again, if I'm saving my work, I'm going to use my snipping tool. New snip. And there is my histogram that I can import into my work file. So this guy right here shows you kind of the distribution, and if you look at it, I'm just going to draw on this, why not? Kind of looks like an exponential decay. And so that's cool, but there's the histogram. How do I do that in Excel? Because I'll be honest, I want more bins. This is giving me like 8 bins or 9 bins by default. I want like 100 bins. Because if I look at, most of the stuff's going on in this first region right up here, and I only have like 4 bins here, and I kind of want to see if there's any, like, if I'm trying to get a good curve, can I get more than 4 data points? More bins. Well, let's look at the mass. So the mass seems to range from 0 to about 100 grams. So I'm going to create 100 bins between 0 and 100 for Excel. This is my penny. I'm just going to close this. Century of pennies. Just going to close this graph I made for you guys to see. Okay, so how do I make a histogram in Excel? So what you need to do is set your intervals, right? Your intervals. So I'm going to start with, let's start with 1, 2, 3, and I'm going to make 100 of these. So let's do that. And then how do I copy it down, by the way? So I can just select the last 2. It sees a pattern between them. Basically, it's adding 1. And see this little box here? You can just drag it down. So I'm going to do that again. So you click 5 and 6, and then see that little box in the lower right-hand corner? It's like a little green box. Click on that. And then just go down to about 100. 200's too much. Ooh, how good are we at mouse holding here? This is probably good, 107. Can I just do it to 107 bins? Okay, let's see. So those are my bins or my intervals. So how do I get Microsoft Excel to figure out histograms for those intervals? So what you're going to do is you're going to go to Data and then Data Analysis. Now, Data Analysis was not on my Excel, but I figured out how to put it on there. I'll show you how to do it right now. The way I did it is you go into File, and then you go down to the bottom, Options, and then you go down to Add-ins. So File, Options, and then you go down to Add-ins, and you click over here where it says Manage Add-ins, you click Go, and this was not selected before. So I select Analysis Tool Pack. This is how, if it doesn't appear in your Microsoft Excel, it'll be an empty box right there. Analysis Tool Pack, and then you hit OK, and it pops up over here. Now those instructions I found from a document I made, and I just want to make sure that that is all I have to do. That's all you have to do. So then this analysis pack, the data analysis thing pops up in your data. So when your Microsoft Excel will probably look like that, and then if you click on data, the data menu, you'll see data analysis. So let's click on data analysis tools. Looks like it gives me different things I can use. It's different packages they've made. So I'm going to type histogram because that's what I want to make. Okay, so input range, bin range. Input range is the data. So I just select the numbers here. So I just can select those and drag down. See that? Now notice what's happening over here to the range. Right now I've got it selected from A2, and that colon means all the way to A310. But I actually want more than that. And as I scroll down, so let me show you. Let me just start over here. I'm going to delete this, and watch what happens as I scroll down. See how the number's going up? It's just going up and up and up. But I already know what my range is. It's going to be A2 to whatever the last one is. So let me actually cancel so I can show you how I did that again. Ugh. Go back up to the top. So so again, we have to do a data analysis, histogram. Okay, input range, and what I'm going to do is select this first one, and then just scroll all the way down to the bottom. That'll take me forever, so I'm going to quit there. And instead of the number 54, you're just going to delete 54 and put in 100,001, which is the last cell. Okay. Bin range, I can just drag these. These are pretty easy. So go to your document and just, you're going to do 1 through 107 or whatever. 1 through 107. Okay, there's my range. Pretty much done at this point. Output options. So let's do it. New worksheet is fine. And let's do, you want to click on chart output. So that'll make your histogram. And this will put it in a new worksheet. So let's hit OK. All done. So here's what happened. Here's my bin number. So it did. Just copied over my bins, and it gave me the number of masses that fit into that range. So here we see there wasn't a lot for, there was none for those, and then the number decreases, and it plotted it. Now I can't really see the graph very easily, so the way you see it better is click on it, click on the corner, and make it big. So here's a histogram of the mass of the particles in the run and the frequency that it occurred. So now we have 100 bins instead of, have 107 bins instead of like 10 bins. So if these histograms are looking at the same kind of data. Here's the other one, right? Nope, that's not it. Looking for my other, it's on the snipping tool. So this histogram that I cut and paste from Easy Histogram is the same data from this set, but like because I've used more histograms, I can actually see more of what's going on in this first region right here. So this first region right here shows some information, and what's interesting here is this little bump right here. This little bump is an interesting thing that is happening. Could this be something. Could something be happening here? And so this is how scientists at the Large Hadron Collider discover new particles. They run lots of trials, hundreds of thousands, this was 100,000 trials, but they actually do as many trials as they can, and they're doing this all the time. They get a lot of data. And what happens is, after a while, they have bumps in the data that can only be explained because they have enough data trials as significantly, like it's significant enough that it has to be a particle. So they use probability and statistics to try and figure out how many trials they need before they can claim they've discovered a new particle. Okay, so this is interesting, right? And this is kind of like where we're going. We're going to be using Scilab to create this histogram as well next time, and it'll be a lot of fun. But anyway, by the way, what happened to my data? So this is a new sheet. If you look down here, this is my Excel spreadsheet. It's called Mu Run 2010B. So this was run in 2010, I'm sure. And where's my graph? It's in this sheet 1. I often rename these, so you can right-click on these and just rename it. So I'm going to call this the histogram tab. It looks like it made a new tab. Histogram. So that's the histogram of the mass data. So what I want you guys to do is create a histogram like this in Excel, or using Easy Histogram Maker for a data set. And since you already know what it looks like, you can do that. You can do that like what you see here, or you can use one of the other data sets. You can use less points. It'd be nice if you guys didn't use 107 bins. So I'll write in the assignment, use another bin size. Maybe maybe you're only interested in the first 40 bins. So like, were there data points outside of 107? Sure. If you go down to the bottom here, Excel will tell you how many data points there are. So if you look at this more column right here, what this means is there's 13 mass events that were more than 107, and they're not on the graph. So, try to use Excel to make the first 40. That'll be a fun look at how the bin size can change the effects of these. So anyway, see if you can find a particle. How do I know what particle this is, by the way? And is this first thing a particle, or is this just noise? Is it actually, maybe I need to zoom in more here with bins. Make my bins like 0.1 and see if it is a bump somehow. I don't know. But like you can actually look it up, the mass of a particle with 10 MeV. I think this is actually GeV. 10 GeV particle. So look that up. What particle has 10 GeV into Google? That would be an interesting question, because I bet there's one there. I bet that. So there's a particle. This is not we didn't just discover this. We're not going to win the Nobel Prize for doing our activity today. Sometimes you win a Nobel Prize when you discover a new particle. So if you get new data set with the highest energy possible, like imagine there's some energy out here that we don't. It's hard to discover particles out here because there's no data. But if we create a particle accelerator with lots of data points and we find a huge bump right here, then we win the Nobel Prize. So what particle has 10 GeV mass? Mass. Which particle is mass 10 GeV? Because that's what we're measuring here, is the mass of it. So anyway, that would be an interesting question to see if you guys can figure it out. So sometimes these particles have weird names, and so you might be like, well, I never even heard of that. But then again, particle physics is this fun area where they're constantly making new names. Anyway, high five, everybody. I'm going to keep the lessons a little shorter because, Shorter is good. All right. See you later, guys.